If you click the link above the screencast, you will be brought to the Simulating Confidence Interval applet made by Rossmann Chance. What you want to do is, over here in the methods, you could choose either means or proportions. I think it's easier to explain what a confidence interval is and what this 95% confidence level means if you're going to use, I think it's easier to use means. So I'm going to select means here. I'm going to sample from a normal population. And typically, when we make confidence interval with means, we use a t instead of a z. Most of the times, as you know, we don't know sigma most of the time. And if we're going to use a z with our sample standard deviation of s, then we know that the t provides better estimates. So I'm going to use a t distribution for my confidence intervals. I'm going to select the mean to be 5. I think it's easier to explain if you're not using a decimal. I'll leave the standard deviation at 10, and I'm going to make my sample size just a little bit smaller because I want to take 100 samples, and I don't want to confuse you, or when you're using this with your students. I think it's better not to have the sample size and the number of intervals you're taking be the same number. Okay, so if you click this sample here, okay, what happened was 100 samples were taken. This is the last sample that was taken of size 90, and you see the mean and the standard deviation there, and then a confidence interval, and in fact 90 confidence intervals were constructed using the sample mean. And you could see in green, those are the confidence intervals that were successful in capturing the true population mean of 5. Right, so this line right here is 5, and all of the green confidence intervals that you can see are touching the 5, which means 5 is contained within the interval. And then the red intervals either lie completely to the right or completely to the left of this 5, which means they were not successful in capturing the true population mean of 5. Now, what's cool about this is when you want to explain this to your students, you can explain what this confidence level means using this picture. You could say that if 100 confidence intervals, if 100 samples of the same size, in this case 90, were taken and confidence intervals were constructed, about 95% of them would be successful in capturing the true population mean. And as you can see right here, we have 92% of the confidence intervals were successful in capturing that 5. You could resample and take another 100 samples, and this applet will give you the count of how many out of those 100 were successful in capturing the 5. In this case, it was 97%, and then it also keeps the running total, which is 94.5%. So 189 out of the 200 were successful in capturing the true population mean. And you could keep drawing samples and constructing those confidence intervals, and then you could explain to your students how this 95% means that 95% of all the confidence interval constructed are successful in capturing the true mean, and you could see we have 94.9% were successful in capturing that mean. Okay. Over here is just another way to display that data. These are all the means. I believe it's just the last 100, and you could see that the 4 were not successful, and those are the 4 confidence intervals right here in red. So I think this is a great applet to explain what it means when you say you're 95% confident. You could also change the confidence level if you wanted to make it 90%, and then you could recalculate, and it'll start over calculating the confidence intervals for you. I'd also mention to your students about how if you increase the sample size, okay, I doubled the sample size, how that's going to reduce the margin of error and help make better predictions and more precise confidence intervals. And also, if we reduce the sample standard deviation, how more precise intervals are going to also be constructed.